Okay, welcome back to Physical Science Online Edition. Today we're going to be doing a lab. Most of the time I feel kind of sorry when you're missing lab day. Today is probably one of those times you're glad that you're on the computer watching this lab. This is a longer lab. It takes a while to do. It's kind of I always tell people it's kind of like watching paint dry lab. This is our boiling ice lab. What I have set up over here, and it's already cooking, is a hot plate with a glass beaker full of ice water in it and a thermometer. And what you would do is, for the next 20 to 30 minutes, is every minute you would be recording the temperature of this ice water and observing some of the changes that happen. And that's how you would spend the whole period. And yeah, it gets a little bit long, especially in the until the ice starts melting. So I'm going to try to do this time-lapse style and just kind of, and then I'll give you some data afterwards. So every minute I'm going to write down the temperature that's on this thermometer, and I will provide that data to you in a separate video when we do our graph analysis. But for right now, I'm going to pause it, and I'll come back in a minute or two when some changes start happening. Okay, now we are roughly 2 minutes in. I just did my 2-minute check. Temperature is holding pretty steady when you get it up here by the ice, because remember the hot plate is messing with stuff, so when I measure, I'm bringing it up just a little bit. And it's holding at roughly 5 to 10 degrees Celsius, changing not too much, mostly just based on where I have the thermometer. And remember that's consistent with our heating graphs because we have the ice taking up all the energy. So the phase change from solid to liquid is taking up all of this heat energy right now and keeping this liquid, the container, at roughly the same degrees. And it's not quite 0 degrees because some of it is liquid and we have that heat transfer going on. So that consistent 5 degrees is the closest that we can come in a simple lab setup like this. I'll come back in another few minutes. Okay, we now have most of the ice gone. We're at around 4 minutes. It's our 4-minute check-in. And one of the common mistakes at this point for most students is to measure the bottom of the liquid. And where it jumps up to like 15, 20 degrees right around now. You'll see that in my data table because I just wanted to prove that life isn't perfect. But actually, if I bring the thermometer up where the ice is still left, I'm still getting around 5 to 10 degrees Celsius. And that's once again just because of that phase change as the heat travels through the water and the energy gets up there. It just isn't consistent because we aren't using very nice equipment. That'd be equipment error if you're keeping track of your scientific error. But I can get better results by moving up here. And the next time I check in, I think all of this ice will be gone. Okay, now we're at about 7 minutes in. All the ice is, of course, gone because we're up to about 40 degrees Celsius. And one of the cool things you can start noticing in this middle section, which is the part that's usually like watching paint dry, is the density of water changing. So all these ripples on the bottom of the camera, that's not from me stirring it. That's because the water closer to the heater is actually expanding because it's getting more energy and it's becoming less dense and it's trying to float to the top. And that's how water can cycle through a little bit. This middle section is so slow because water has a really high what's called specific heat too. That's kind of just a side note, not going to be on the test. And that just means that water takes a lot of energy in order to change temperatures. So that's why you might be thankful to be sitting at home while I do this one. I'll check in again once we get closer to boiling. Okay, about 12 minutes in now. We're up to 80 degrees Celsius. And at 80 degrees Celsius, which is not the evaporation or boiling temperature of water, you still see steam coming off and a couple small bubbles at the bottom. That's because we are starting to get close to the energy and some random particles are reaching the correct energy. I'll get one last check-in before I have to end the video. Okay, 16 minutes in and we finally have reached 100 degrees Celsius across the whole sample of water, which is the boiling point. Boiling is when evaporation is happening super rapidly because the whole substance is at its evaporation point. That's it for this lab. Thank you and have a great day.